This is section 13.4, part 3. We're still working on parabolas, and we're still going to be doing some graphing of parabolas. But today, we're going to talk about, in the notes, identifying conic sections by their equations, the different types, an ellipse, a circle, hyperbola, or parabola. So let's look at how we identify them. It says, recognizing conic sections from equations. A circle. If you have a circle, and a circle you can tell by when you have x and y squared are on the same side, so you're going to have to get them on the same side of the equation here. If they have the same side and they have the same number in front, and so this one has ones in front, these coefficients are ones, but it might not be ones. You could have something like 4x squared plus 4y squared equals 36. It doesn't matter. If you have the same number in front and you have an addition here, then you have a circle. An ellipse. You're still going to have addition. You have to get the x squared and y squared on the same side again, but they're going to have different coefficients. Like this one here has a 4 as a coefficient and a 16 on the y. If they're different and still plus, then it's an ellipse. And a hyperbola, you're going to have subtraction basically. When you get x squared and y squared on the same side, it says the coefficients have opposite sides. Well, you're going to have either a negative, depending on where you put the minus. You're either going to have a negative in front of the y, or you're going to have a negative in front of the x squared. Sorry, in front of the y squared or in front of the x squared. Like this one, actually on both of these, they're both in front of the x squared. But it also could be a negative in front of the y squared. Usually we'll write it as subtraction. So if you see subtraction, it is a hyperbola. But they both have to be squares, a subtraction with both squares. And then a parabola, if you only have one variable that's squared, either a y squared, or you could have one that has an x squared. For instance, if we had y equals 3x squared plus 2x plus 1, this would also be a parabola. You only have one x squared. That's the key for a parabola. So let's look at a couple of problems. It says indicate whether the graph of each equation is a circle, an ellipse, a hyperbola, or a parabola. The first thing you need to do is you have to get the variables on the same side, assuming they both have squares. If we only have a variable with a squared, then you know it's a parabola automatically. So we're going to have to add 4x squared to the other side. Okay, when we do this, we're going to usually write with addition, you write the x squared first, so 4x squared plus 4y squared equals 16 now, because these cancel out. And you can see we have an addition, and these two are the same coefficients. Okay, if the coefficients on each variable is the same, then what you get is a circle. All right, and B, subtract the y squared over. And in subtraction, you usually write whatever's negative second. So you got x squared minus y squared equals 9. And anytime we have subtraction, then you get a hyperbola. Oops. Oops, forgot my B. Can't spell today. All right, on C, you can see here we've got an x, we got a y, and we got a y squared, but we don't have an x squared. So there's only one squared. If there's only one squared, it's automatically a parabola. And D, we got 2 squared, so we're going to add 16y squared to the other side. And you usually write the x squared first, so x squared in addition anyways, plus 16y squared equals 16. And if this coefficient was 1, we'd have different coefficients. So different coefficients, which means that we have a ellipse. All right, so pause here, try your checkpoints on the next page. When you come back, I'll give you the answers. All right, so checkpoint A is hyperbola. B is an ellipse. C is a circle. And D is a parabola. I'll see you in class to give you your assignment.